Just like to talk briefly about switchboards, past, present and the future. AS3439 has had several additions. Prior to AS3439, the standard was AS1136, which I'll briefly summarise. 1136 originally came out in 1974 and had three forms of separation. Form 1, Form 2 and Form 3, being no segregation, 2 partially segregated and 3 fully segregated. In 1988, the forms of segregation changed from 3 forms to 4, being Form 1, no segregation, Form 2A and 2B, partially segregated, and Form 3, fully segregated. 3439 was published in 1993. There's now the forms of segregation have changed to forms of separation, not segregation, forms of separation. There are now 5 forms of separation. Forms 3A and 3B have now been added. In particular, Form 3B permits terminals to be separated from the functional unit and for external conductors in a common area, but not from each other, with Form 4 being added, which is full separation. This included the terminals for external conductors, which are an integral part of the functional unit. In 2002, when 3439 was updated again, there's the H&I variance, which I won't talk about at the moment. But it still remained Form 3B, which permits terminals to be in a separated from the functional unit for external conductors in a common area, but not from each other. It changed the Form 4 from 4 to Form 4A and Form 4B. So just quickly, there is no Form 2, there is no Form 3, there is no Form 4. It's 2A or B, 3A or B, or Form 4A or B. I've read on many occasions since 3439 was first published that a Form 3B switchboard is specified. The problem is a Form 3B switchboard to 3439 current standard is not a fully separated design. When the specifications have been changed, I believe that in some instances 1136 has been deleted and 3439 has been added. This has resulted in an inferior switchboard design than what was really intended. A Form 4A switchboard, in accordance with the current standard, is a Form 3 switchboard to AS 1136 1988. So what we're looking at there, this is a Form 4A, and you'll note that I've called it Form 4A, but there's a couple of additional notes that should be noted there. You'll see the red, white and blue phase bus bars feeding the circuit breaker. That's an additional requirement that most switchboard manufacturers put in. However, it's not a requirement for the form of separation for that to be there. It's an additional safety measure, and that particular cell has a rotor end interlock as well. I believe a Form 4A switchboard is what is generally required in this day and age, provided that additional insulation and an interlocking handle is in place. It is perfectly acceptable to specify a Form 3B switchboard, but that is when the ability to turn the entire switchboard off is available before any electrical work is conducted. Unless the switchboard can be fully isolated, it places an electrician in a dangerous workplace. It means an electrical worker opening a cable chamber will be faced with live, unprotected outgoing terminations. I ask, what are our obligations to RHS and a safe work environment that are required today? Is a Form 3B switchboard acceptable? I believe a practical and safe form of separation is a Form 4A switchboard with the additional requirements of the insulation on the line side of the feeder conductors and also an interlocked circuit breaker handle, so that when the door is off, when the circuit breaker is off, you can open the door. When it's on, you can't. Is Form 4B safer? Yes, it is, but that also has some problems, being that the cable connections are in a separate compartment, and it is possible that somebody that's not paying particular attention could open up a cover and get access to live conductors if they haven't isolated the upstream unit. Some switchboard builders are not interested in selling at a technical level, they sell on price only. They take the approach, it's a box with stuff in it, they don't understand the implications of what they're doing and how they design a product. They do not take the approach that someday something will happen. People who take the time and effort and have the resources to first design something, commit their money to going to test and take a different approach. They know that over the lifetime of building switchboards, one day an incident may occur. Hopefully it'll just be an incident and not an accident. During the last 30 years, I know of at least 30 major electrical incidents that have shut down a switchboard for a period of time. All were built by reputable switchboard manufacturers, all were of a partially type-tested design, and they were based upon type tests. All were caused by human error. In all of these switchboards, in all of these incidents, the switchboard was designed and built, did exactly what the type testing said it would do. The switchboard design contained the problem, the faulty part was removed, and the switchboard removed from service. Going back to my original statement about selling on cost. So what, you ask? Let's assume there was an incident. Instead of worrying about the cost of a switchboard, think about the cost if you're the electrical contractor, signed off on the certificate of electrical safety, if the switchboard wasn't built to the standard. Think about the cost if you're an inspector that signed off on the project that is not built to a standard. And think about the cost if you're a consultant that has signed off on a project that is not built to a standard. Imagine now that it's not an incident but a fatality, and all parties in front of the coroner's court. WorkCover investigators and Energy Safe Victoria. It's a world of pain, and I wouldn't wish it on my worst enemy. It'll be no defence to say, but all I did was install a switchboard. It's the manufacturer's fault. It's the REC that submits the certificate of electrical safety, and it's the inspector that signs off on the installation, not the switchboard builder. The coroner won't accept an argument that it was someone else's fault. Portions of the blame will be allocated to everybody involved in the incident. NESMA has tried for years to get all electrical switchboard manufacturers to join our association. Many have joined, some don't. Remember, something will happen eventually. That's when you need to be able to stand with your hand on your heart and say, I did what was needed, my work was sound. You don't want to be just getting by because someone else said so. Do you really want to put your financial future at risk by placing in such an important item, the most critical item in any electrical installation, in the hands of a manufacturer that cannot produce a type test? This isn't an opinion. It's legislated by law, being AS 3000. AS 3000 2932 says, switchboards shall be suitable to withstand the mechanical, electrical and thermal stresses that are likely to occur in service. It also goes on, switchboards complying with the relevant standard, 3439, are considered to meet the requirements of this clause. The front cover of 3439 is low voltage switchgear and control gear assemblies. Part 1, type tested and partially type tested assemblies. A partially type tested design is a design calculated from known results from a type tested switchboard. It is not a box with switchgear in it and bus bar supports have been thrown together. A bit of this here and a bit of that there. I'll say again, this is not a partially type tested design. It's perfectly acceptable to use proprietary purchase bus bar supports, associated plugs, components, a chassis, but they must be backed up with complete testing. Type testing. One of our manufacturers, one of our suppliers here, Kentan, sells some of these products and is able to assist with manufacturers. I know, I still use some of them, but it's only after I've done my own testing. Our major sponsor, IPD, sells L-Steel. They're able to assist any manufacturer that does not have the resources to do their own testing. I don't have a problem with this arrangement because I know the product is sound. So what's that mean? It means an installation built to AS 3000 must have a switchboard that is in accordance with AS 3439, and it must be either a type-tested or a partially type-tested design. I believe that's also an obligation of the inspector to ask for and review the relevant certification on a switchboard and to verify its compliance prior to energisation. NESMA is actively lobbying to lift the standards across industry. You can't just get by. The future will be characterised by one word, and that word is verification. At the last EL68 meeting, the timeframe was put in place to implement the new Australian standard. The new standard will be in place within 2 years. The new standard will be AS NZS 61439 low voltage switchgear and control gear assemblies general rules. Please note, it does not say type tested assemblies or partially type tested assemblies. If you want to know how this standard will read IEC 61439. The new standard is cloned from it, word for word. Australian annexes will be added, but these have not been confirmed yet and what they are. The word is verification. The previous standard was all about type-tested and partially type-tested assemblies. There are still tests. These are now called verification tests. There are significant changes to testing and results from testing. Some results and tests from previous standard will still be valid. These are especially relevant for short circuit tests and through fault tests. Changes have been made, as one of our other speakers spoke about, in regards to temperaturised tests. Some other verification tests that are in the new standard are a lifting test by verification, a corrosion test, and an impact test. I'll say it again, verification is the word. Australian switchboard builders should not be afraid of these changes. They should embrace them. They cannot be ignored. These changes are game-changing to our industry. NESMA is actively working to implement these changes. Thank you for the time. You've heard my thoughts on the past, the present and the future. I believe in NESMA and its slogan for the advancement of the Australian switchboard industry. Thank you.